First step that we will do is factor. We will factor both the numerator and denominator. Yesterday we weren't really concerned with the numerator, but it will help us find if anything cancels, which puts a hole in our graph. It'll also make finding our intercepts a little bit easier, so we will factor everything. Write it in lowest terms. We'll figure out if we have any holes, which happens when things cancel. Then we'll do our x and y intercepts, which we mentioned yesterday. X-intercept, that's when y equals 0. Y-intercept is when x equals 0. Vertical asymptotes, which we talked about, that's when our denominator is 0. Figure out horizontal or oblique, and then we'll plot all of that stuff on our graph and use the graphing calculator to fill in the gaps to draw the final piece. Okay, so we have done all of these pieces individually. Now we're just putting it all together to draw a nice graph at the end. I want to mention the holes one more time. We have touched on it before, but I want to make sure everybody is aware what creates those. So the hole happens when something cancels out of both the numerator and denominator. For instance, if I have x squared minus 9 over x plus 3, x squared minus 9 can factor into x plus 3, x minus 3 over x plus 3. What happens here?
Cancel.
X plus 3 cancels and you get x minus 3. So our graph will have a hole at the x value is what makes this thing equal 0. So if x plus 3 equals 0, that means x is negative 3. So that's the x value. To find the y, you plug the negative 3 into what's left. So negative 3 minus 3 gives us negative 6. So when I go to draw my graph, I will draw an open circle at negative 3, negative 6. We may or may not have any examples that actually have a hole in them today. We are going to spend the next few days graphing, so we will get to those. But we're not going to start out with them. Any questions?
Wait, what did you do in the bottom left corner?
I just figured out the x value of the hole, which is whatever cancels, what makes it 0.
Oh, so you don't do the, yeah.
This one is to find your y.
Oh, okay.
So if like an x minus 5 canceled, then 5 would be my x value, and I'd plug a 5 in here, and my y would be 2.
So to find your x, you use the ones that you cancel.
Mm-hmm.
What, is there ever going to be more than one you cancel out?
There could be. I probably won't give you one that complicated, but it is definitely possible. Yes.
So the arrow,
Mm-hmm.
what is that for?
That was showing you how to get your y value. So let me just do another one real quick. I think that'll help. If I said like x plus 2, x minus 4 over x minus 4, x plus 1. What cancels there?
X plus 4.
Okay, and you're left with x plus 2 over x plus 1. So the hole there would be at your x value is from the thing that canceled. So what makes x minus 4 0? 4. So there's our x. To find your y, you plug a 4 into what's left. So 4 plus 2 over 4 plus 1 would give me 6/5 for my y.
Will something always be able to cancel out, or do we have to always make it to where it can get canceled out?
It will not always in a problem, and if it doesn't happen, then we don't have to worry about this. So the only time we have a hole is if something by chance cancels.
So if there isn't a hole, what do we put down for that?
You won't have to list anything. Other questions? So I want to just jump in and start graphing these things. Keep that handout in front of you so you can look through the steps that we are going to go through as we find this. So here is my first function. R of x equals -1 over x squared plus 4x plus 4. Okay, first step is what? Factor everything. So, -1, I can't factor that. The denominator, though, we could factor. X squared breaks into x. What multiplies to 4 and adds to 4? 2 and 2. You're welcome to write that as x plus 2 squared. It doesn't really matter, so I'm just going to leave it as I have it right now. Step 2 is to cancel anything that happens to drop out. Do I have anything that reduces? No. So we just skip that and we move on. We need our intercepts. An x-intercept. How do you find an x-intercept? Yep. Y equals 0. So that's like your R of x. If you set a fraction equal to 0, the first thing you're probably going to do is get rid of the fraction, right? If I multiply my denominator over, what's 0 times anything?
0.
So I just get 0 equals -1, so what does that tell me?
None.
None. 0 can't equal -1, so in this case there is no x-intercept. If you recognize that every time our first step will be to multiply over your denominator, and every time that denominator is just going to cancel, you can shortcut this a little bit. The x-intercept is really what makes the top of your fraction equal 0. So if you recognize that, great. If you don't, it's one more line to write out, so it's not like it's a big deal. How do we find a y-intercept? Question?
I have a question about the x.
Uh-huh.
So will it always be none since everything, or just when that?
If it's just a number on top, it'll be none. If it's for like x plus 3, we would have gotten 1.
Okay.
So it's because there was no variable in our numerator.
Because we had to multiply because it's a fraction.
Mhm.
Okay.
Y-intercept means you plug in a 0 for all of your x's. And I get a -1/4. So we've done x and y intercepts a lot with other equations, same process here. Vertical asymptotes. Vertical is x equals what makes the denominator 0. What would that be? -2. It doesn't matter that there were 2 of them, you only have to list it once. Now we need to decide if we'll have a horizontal or oblique. And remember, that's based on your degree. What's the degree of this numerator? 0. There are no x's. What's the degree of the denominator? So the top is smaller. That means it is horizontal. Y equals 0. Anytime the top is smaller, it's always 0. And since we have a horizontal, we don't have an oblique. So now we draw a graph.
And if the top is 1 more, then it's a
Yes.
right. This one
I had you find all of this for a reason. I do expect you to plot these things on your graph. I don't touch the x-axis. I touch the y-axis at a -1/4. Vertical asymptote at -2. We draw those asymptotes as dashed lines. Horizontal asymptote at 0. So that's just the x-axis. And then what you can do is use your graphing calculator to help you fill in the rest. I recommend graphing the original. That way you'll kind of catch any mistakes you might have made along the way. Make sure if there's multiple terms, you're using parentheses around your numerator and denominator. So I want everybody to graph it, and that way if it doesn't work for you, we can figure out what went wrong. Did you guys get 2 downward curves here? So a couple things I want to mention. If you draw this, I'm going to count it wrong. What is the role of an asymptote? What does that do to your graph? You're getting closer and closer to it, right? So you should draw your curve getting closer to your asymptotes as time goes on. It's not actually crossing them, but it's getting closer. Make sure that's obvious. Then over here, you need to make sure you are going through the intercepts that you have marked. So that should be our graph. You got it.
Yes. On the first, I have it upside down for
You did do parentheses.
I know, right?
Anyone else have any problems with that, Jordan?
Well, no, it's beautiful.
Yes. Didn't do parentheses around the denominator. Okay, anything else? So this is all we're doing today. We're just going to keep practicing this. And that's it for today. Let's look at okay, first step is to factor. X squared, you could write it as x times x, but you don't have to. But what could I do with x squared minus 4? Okay. Same thing cancel? No. So then we go into our intercepts. So the x-intercept. I've told you that's when y equals 0. What would you do first? Multiply the x squared, and 0 times anything is still 0. So really, you could have just jumped straight to this. It's just what makes the top of the fraction 0. So what makes x plus 2 0? And x minus 2? 2. So our x-intercepts are 2 and negative 2. If you want, you can go ahead and plot those on your graph. Okay, hit the x-axis at negative 2 and positive 2. Twice. How do you find a y-intercept? Plug 0 in for x. You could do it at the original, you can do it on your factored form. It doesn't matter. Can you have negative 4 divided by 0? So what does that tell me about the y-intercept?
0.
Not 0, none. We don't want to say that we cross the y-axis at 0, we want to say we don't do it at all. Vertical asymptote. X equals, what makes the bottom 0? 0. So if you want, you could draw that. The y-axis is our vertical asymptote. To decide horizontal or oblique, we need our degree. What's the degree of the top? Degree of the bottom? If it's the same, you said that means horizontal, bless you. So y equals, and you divide the leading coefficients. So this is a 1x squared over 1x squared. 1 over 1 is 1. So horizontal, y equals 1. Now, graph, I recommend going with the original. The numerator, make sure you're using parentheses because it has more than one term. Graph x squared minus 4 divided by x squared. And you should see both of these are again going down. Make sure when you draw it, you go through your x-intercepts and get closer to your asymptotes. They are curves, not straight lines. So it looks something like that. Is that okay? Let's try some more. So first step is factor. Can't factor x minus 1. X squared minus 4, that would be? Okay. Nothing cancels. Can you guys just look at this and tell me what your x-intercept will be? 1. It's just when the top of the fraction equals 0. So our x-intercept is 1. Y-intercept, if you plug in 0 for all of your x's, you could do it anywhere. I'll just do it in the original. You get -1 over -4 or positive 1/4. What's my vertical asymptote? How many do we have?
2.
2 of them. What makes x plus 2 0? And x minus 2 is positive 2. So 2 vertical asymptotes. Horizontal or oblique? What's the degree of the top?
1.
Bottom? So the top is smaller, that means?
Y equals 0.
Now, this may seem a little odd. We have a horizontal asymptote and I also have a point on that line. It is okay. These horizontal asymptotes mean at the ends you're just approaching it, but it is possible that you might cross it in the middle. So that's not a big deal. Now we need to graph the original parentheses on top and bottom. the bottom left, you've got what looks like kind of like a cubic in the middle going through your intercepts. And then you have this upper corner here. Your vertical asymptotes kind of separate it into pieces. So when we only had one vertical asymptote, it broke it into 2 pieces. We had 2 vertical asymptotes, it broke it into 3 pieces. Because you have everything except those. Questions there? We're going to do at least one more, possibly 2, and then I'm done. First step, factor. What would you do to the top? Plus 1, x minus 1. Bottom is just an x, so we can't do anything. Can you just look at it and tell me the x-intercepts? Just the things that make the top of the fraction 0. Does everybody understand that? That's why it's really nice at the top is factored. You can get those out really quickly. Y-intercept, if you plug in a 0 for x, I'll just go back to the original and put that in. I get -1 over 0, so what does that tell me? None. Vertical asymptote, x equals 0. So that's our y-axis.
So the vertical is at the bottom?
Yes, vertical asymptote is what makes the bottom 0. Horizontal or oblique, what's the degree of the top? And the bottom? So what does that mean? Oblique, how do we find it? Long division. So our x will go on the outside. X squared, you could put in a 0x if you want. Minus 1 goes on the inside. I'm going to move that down there so I've got more space. Okay. X squared divided by x. X times x is x squared. Subtract those off and they cancel. Bring down to 0x. What's 0x divided by x? 0. So our equation is just y equals x plus 0 is just y equals x.
That's weird.
It's kind of a nice one, really. So to graph this, it's just a line. Y equals an x plus b. My y-intercept is 0. Slope is 1, so up 1 over 1. Drawing in your dashed line. So now, graph your original with parentheses.
So obliques are always going to be like diagonal?
Yes. So this first piece, it looks almost like a flat line. It's really just getting closer to your asymptote. So it's something like this. Looks kind of like that. Excuse my artistic ability. Are you guys getting those on your calculators okay? How do we feel about this? Do we want to do another one together, or do you think we got it?
I do another one like this one.
Yeah, I'll have to make one up. I don't think my next one has. Yeah. Let's do. Here, I'll just do this. I'm just gonna change it. I'll make it x times x plus 1 over x plus 4. Okay, this one is factored for me, so I get to skip that step. Nothing cancels, so we get to jump right to the intercepts. What are my x-intercepts? What makes the top 0? Cross the x-axis twice. 0 and -1. Y-intercept. If you plug in a 0 for all of your x's, you get 0. So that's just there. Vertical asymptote. What makes the bottom 0? -4x equals -4. Horizontal or oblique. Now this one is slightly different because the top is factored out. But think about it. If you multiply the top, you'd have an x squared plus x over x plus 4. So what's the degree of the top? 2. The bottom?
1.
So the top is 1 bigger, so that means it's oblique. We do long division. So the x plus 4 goes on the outside. X squared plus x, if you want, you could include a plus 0 on the inside. Okay. X squared divided by x. Okay. Multiply x times x is x squared. X times 4 is 4x. Then what do we do? So x minus 4x is -3x. -3x divided by x. So our oblique is y equals x minus 3. Okay. So to graph that, just a line, y-intercept of -3. Slope is 1, so up 1 over 1. When you go to graph this, I want to warn you. If you want to plug in the original, that's great, but you have to have an extra set of parentheses around the top because it's two things multiplied.
I'm just like confused how you grab the oblique.
It's just like graphing a line, y equals mx plus b. You start at your y-intercept, which is -3. This was a slope of 1. So if you're graphing the original, you need 2 parentheses on top. You do a parenthesis x, then another parenthesis x plus 1, and close both of those. When you graph this, you're not seeing everything. We can adjust our window. We see this kind of parabola looking thing. Keep in mind, it has to hit both of these points, so what it's going to do is go through this, come back and hit this one, and then we're getting close to our asymptote over here. If you zoom out, you will see we have to have something on both sides of the vertical asymptote. Your graph is only showing you one side. We also need something over here. Now we could probably figure it out since you're not seeing it on the calculator. Is it up here or is it down here?
Down.
It's going to be down here. You could also zoom out on your calculator and it would show up then as well. Just keep in mind you have something on every side of your vertical asymptote. So if you're not seeing it all, you may need to zoom out in order to do so. Any questions there? I have a handout for you, and you've got quite a bit of time to work